This is one of the best non-reinforced ABS materials, and this is the carbon fiber version from this video, the weaker one. Even if I already did a creep test with this test object, it still has less deformation here. Hello, welcome to another very interesting filament testing video from two reasons. One, I checked the summary table from pattern supporters and I noticed that I never tested the ABS filament reinforced with carbon fibers. With glass fiber, yes, but with carbon fibers, no so far. And immediately I have here two types. One is the regular carbon fiber and the other is the core version where we have those fibers inside the filament. These two spools are sent to me by the Siraya Tech for the testing and review video, but there is no additional payments, so this is not a sponsored video by Siraya Tech. This channel has its own sponsor and that's the polymaker. Now let's see some specifications. About ABS-CF. It contains 10% shop carbon fibers, it is heated chemical resistant material, and it has dimensional accuracy and great rigidity. And now about the core version. It contains 20% core concentrated carbon fibers, and with this we have all those advantages of the core filaments, like a stronger layer adhesion, reduced nozzle wear, safer because fiber exposure is reduced and we have smoother surface. It is heat resistant and it can be used up to 90 degrees Celsius applications. And now the print settings. The print temperature in both cases are very similar. For the carbon fiber version, the nozzle temperature between 250 and 270 degrees Celsius. On the core version, the maximal is 280 degrees Celsius. The bed temperature is the same, between 100 and 110 degrees Celsius. And of course, we have to use the hardened steel nozzle. The fan between 0 and 20%. And also they mention on one place that it is recommended to use the enclosure with the maximal temperature for approximately 50 degrees Celsius, which can be even passively heated by the heated bed. But in this video I decided to test this finally to see if the actively heated chamber will significantly improve the layer adhesion. If you want to know more about core filaments, I have this very short video, only 3 minutes, and there I explain why the flow is laminar and why do we have all these advantages. Actually, there's one exception. If you use some kind of CHT-like nozzle, in that case we don't have that advantage of reduced nozzle wear because the part is inside the core of that filament. But even in that case, it is recommended to use hardened steel or some kind of wear-resistant nozzle. Let's see what's in a box. Good vacuum packaging, and this material is great against the moisture. I can see the bags are resealable. On a sticker, slightly different informations compared to the website. Basically on the core version, a little bit bigger print temperatures between 260 and 280 degrees Celsius. On the regular carbon fiber between 250 and 270 degrees Celsius. In both cases, the max speed is 200 mm per second and the fan between 0 and 20%. Let's open the bags above the sealing line. So we have the core and the regular version, and on the sticker I can see only here the difference. Quite obvious that this is shinier compared to this one, and for the touch it is smoother. Let's see how brittle is the filament itself. This is the regular carbon fiber version. And this is the core version. Let's measure it. Before the measuring, I want to mention this. Because of the smaller density, they have to place more filament on the spool to have that 1 kilogram. But in this case, I will prefer or bigger spool, or let's say having 0.9 kilograms on the spool. This may fall down during the printing. Like this. This is regular carbon fiber version. Start deformation 25 degrees. I will check the footage, but I think it was 85 degrees. This is core version, start angle 25 degrees. 75 approximately. On the website they mentioned that it is dried before the packaging and we can use it out of the box. Of course, depend if you store it for the longer period, then I will suggest a drying of this filament. Almost all test objects will be printed on Bambu Lab X1 carbon. I will use engineering plate with some glue on it. My X1 carbon is connected to that exhaust hole on the wall. Later, when I will test actively heated chamber, I will print on KIDI +4. The printing I will start with ABS-CF, the regular version. Settings in the slicer. I'm starting from generic ABS profile. The nozzle temperature is 270 degrees Celsius, 15 is the maximal flow, and I reduced the part cooling to only 20%. Later I will test different percentage too. These are my regular test objects. The start is good, only it is hard to see this black color inside. Maybe I should install finally some better lights. Printing will be finished soon. This is the last test object. Enabling the exhaust fan to suck out the air through that ventilation hole. I still didn't install this inline fan. It will help with this because the exhaust fan is a little bit weak for this, but it is better than nothing. The printing looks great. I was worried about those overhangs for these vertical test objects, but it came out perfectly. And now switching to the core version. And the only change is in a nozzle temperature of 280 degrees Celsius. Everything else is the same. And the start is again very good. The printing will be finished in 5 minutes, so later I will analyze them under the microscope. Now I can see on these vertical test objects for the layer adhesion that this curling up starts to be too much. The part cooling is a little bit too low. Those 20% are not enough. Layer adhesion test objects I am reprinting with the default part cooling, which is maximal 80%. And I will have these 6 dies to have more time for the layer to cool down. I think they look much better now, but I will analyze them later. And the third group with 50% part cooling. 50% part cooling. Time to analyze them. This is the ABS-CF and this is the core version, 20, 50 and 80% maximal part cooling. Let's start with these printed on 20%. 20% part cooling, this is ABS-CF and this is the core version, and the regular is slightly better, but even here I don't like this overhang, but this is much worse, and also I can even see here this curling up, so I would never recommend printing with these settings. Now because of that irregular shape, sometimes it even breaks on smaller load, but I will see soon. This is 80% maximal part cooling and it's completely fine. This is the default setting for the generic ABS. But let's see what's between. This is printed with 50% and it's completely fine. This is regular ABS-CF and this is the core version. Let's finally measure the effect of the actively heated chamber, so the only difference will be set temperature to 0 and 65, and I'm starting with 0 degrees. It started with the smallest cross-section area, and according to the sensor, the temperature inside is 37 degrees Celsius. Theoretically, this is the weakest point. The smallest cross-section area is finished, and the temperature inside is 39 degrees Celsius. It's finished and the peak temperature was 42 degrees Celsius on the chamber in 32 minutes approximately, and they look perfect. It didn't even started with the smallest cross-section area, and the chamber temperature is already 64 degrees Celsius. The quality of those overhangs is great in both cases. I use 50% part cooling here, and we will see what's the difference in the layer adhesion. Even for the touch, the core is smoother compared to the regular carbon fiber version, but let's check the surfaces under the microscope. Yes, somebody suggested me to do the stick tape test. And now let's check them under the microscope. This masking tape is not the best for this, but the other one which I had was transparent. I can see these kind of fiber things, but these are too big. These are not those fibers. I have to experiment more with the other type of the tapes. But let's check the filament itself. On the left side you can see the regular carbon fiber, and on the right side we can see that core skin which don't have the fibers on the edge of the filament. And we can see high density of the fibers inside. And this is printed object under the microscope, and we can clearly see those fibers on the left side, but they're not exposed, they are melted into plastic. But the core version on the right side is quite smooth. Measuring the shrinking, this is ABS-CF. The design length is 80 mm. This is very close to that value. And this is the core version. And this is super accurate. I'm so surprised here that I wanted to recheck this with another test object. This is 60 mm in length. This is ABS-CF. and the core version, and I already calculated the shrinking and I compared it to the average ABS. You can see the shrinking values in the corner. And shrinking is one of the reasons why I will go sometimes with the PETG instead of ABS or ASA. Creeps has the deformation under constant load, and regular ABS performed good in this test. I believe that this will be even better. Very minimal deformation and smaller on this core version. 13.49 millimeters. 12.63, smaller deformation. They will be measured every day, but let's jump in the time. Day 5, time for the last measuring. 13.77. 12.73. Let's remove the load. And the permanent deformation is almost zero in both cases. On this graph we can see the distance between two reference surfaces, and we can see noticeable less deformation under the core version, but the creeping is the difference between 2 days, and that we can see on this other graph. And in both cases basically these are extremely small values, but yes, core is better in this case. Tensile test with horizontal printed objects. I'm starting with regular ABS-CF. And now the core version. I will include the data for the average ABS, which is calculated from 14 pieces from the pattern summary table. And we can see that the core version is stronger than the regular ABS-CF, but both are stronger compared to the average ABS. Layer adhesion tests with vertically printed objects. And this is the value for the 80% part cooling and now the 50% max part cooling. And this is with the 20% max part cooling. And now the core version, 80% part cooling, 50%, and 20%, which had some problems with the overhangs, but still stronger. In every case, the core was slightly stronger compared to the regular ABS-CF, and we can see increasing in the layer adhesion with reducing the part cooling. Now, this is the default settings in Bamboo Studio, so probably most of the users will use this. And these two, with 20% part cooling, had some problems with the overhang. It's a little bit deformed, so I don't recommend using these settings. And probably these two I will add to that summary table for my pattern supporters. Let's check the effect of the actively heated chamber, set to 0 and set to 65 degrees Celsius. The improvement was almost 20%. I thought the difference will be much smaller, and this just adds another variable into my future testings. These are printed in horizontal position, and these are printed vertically. In horizontal position, those carbon fibers really helps here, and the core was stronger. Now printed vertically, I thought that the core will be again stronger, but basically the difference is very minimal, only 2%. Torsion or twist test with horizontally and vertically printed test objects. 1.3, 1.5, 1.3, 1.6. 1.4, 1.5. No big surprises here, but it was really nice to see that I could make almost 90-degree rotation with these vertically printed test objects from the core version. Both carbon fiber materials are stronger compared to the average ABS, non-reinforced, and the core was the strongest between these two. And now 3-point bending test. Distance between supports is 50 mm, and these loads will be placed one by one, and I'm measuring the deformation after 130 and 60 seconds. Side by side two materials, deformation under 1.25 kg, under 2.5 kg, under 5 kg, still no additional deformation during the time, and only here under 10 kg I can see some additional deformations. Smaller values are better, less deformation, and we can see that the core is better compared to the ABS-CF, less deformation, but both are very good compared to the non-reinforced ABS. Additionally, under 10 kg you don't have that significant additional deformation during this 1 minute, unlike the average ABS. Impact test, and usually ABS is tough material. ABS CF, 0 position, core version. Not sure is it important, but this is the regular and this is the core version. In both cases we can see this white surface, but let's analyze the footage. This is the 0 position, and this is after breaking the ABS CF, and this is after the core version. And we can see that the core is tougher compared to the regular ABS CF, but both are quite brittle compared to the average ABS. Temperature test in the oven, regular and the core version. The average ABS starts to deform in this test at approximately 90-95 degrees Celsius. In this case, these temperatures were slightly higher, and the core version was better in this case. I stopped the experiment on 146 degrees Celsius, and on these temperatures both materials are quite soft and elastic. And one more time our results. This is the result of the tensile test, layer adhesion test on different part coolings. This is the effect of the heated chamber, shear test, bending test, deformation after 30 seconds, bending test, deformation after 130 and 60 seconds, torque or torsion test, impact test, temperature test, and shrinking. This was quite big work, but at least I don't have to anneal these materials, unlike those in upcoming videos. And basically, if you like ABS and you're not afraid of those deadly carbon fibers, thanks to some clickbait videos, then you will like this material. Or at least we have that core version where we have that smooth surface even outside. But I check under the microscope, even the regular ABS CF has melted in those fibers into plastic. Of course, I wouldn't use them in some part which has some friction, for example this release element on my friction pendulum, but for these brackets it's completely fine. And looks like the only disadvantage I could find compared to the regular non-reinforced ABS, that it is more brittle, resists less to the impacts. Otherwise this is really great material. A huge thanks to all my Patreon supporters and also to the Polymaker for sponsoring my videos and complete channel. And to all of you others, thank you for watching this video. Don't forget to subscribe and enable that notification bell button too, because in most cases the notifications is not sent to regular subscribers, only to those who enable that notifications. But anyway, thank you for watching this video and happy printing.